A few days ago I published this circuit on YouTube. It was the Schmidt trigger revisited, and there are more videos about Schmidt triggers on my YouTube channel. You can go to the looking glass on my YouTube channel Radio Fun 232 and then search via keywords like Schmidt trigger, audio amplifier, shortwave radio, shortwave, etc. etc. That is not the aim of this video. This was that first schematic, and the interesting thing, or perhaps not interesting, is that this circuit worked with a positive voltage. So when the voltage here on this electrode got more positive, the Schmidt trigger switched. But I found today an old project where I tried to reverse that in a certain way and make a switch amplifier that does not switch on a positive voltage but on a negative voltage. And that schematic is here. In fact, it's very simple. Here is it on the breadboard, and I will try to give a demonstration. Here 2 voltmeters. This is the voltmeter regarding the supply voltage to the circuit that has to be stabilized, and I've stabilized it with a 7812. And here the voltage on the input, it's a negative voltage opposite to ground, that is 0 in this case, and that's why you read here minus and 0. So we add here, to be more precise, here, this part of the circuit here, we add a negative voltage that will pinch off the transistor that does the job, say by activating or not activating the relay. This is a 12 volt relay, 280 ohms when you measure it with an ohms meter. And of course you can say, well, this is kind of overdone. Why have I used this transistor here? Because when you say pinch off the base of a NPN transistor to the minus, and that's here, it also can act as a switch. But that is somewhat problematic. And that's a reason why I've used here an extra transistor, and this works much better. And also the good thing of this circuit is that you can set with this 47K potentiometer the whole circuit to a precise negative voltage where the circuit switches. Does it switch exactly like the Schmidt trigger? I don't know. I have to study that further, but of course you can also do your own experiments, and I'm absolutely sure that it's a useful circuit that can be used in many cases. Where you need a negative voltage, it has to switch a relay or so. I've used a 7812 voltage stabilizer. That's of course necessary. It's a kind of measurement circuit. You need a stabilized voltage because when the relay starts to take current, when there's no stabilization here, the voltage will drop, and that means that the switch moment is no longer precisely defined. That's why you need here voltage stabilizer. You can use this. You can also use another type of voltage stabilizer, but this is, say, the easiest and the cheapest way. I want to show now how the circuit works and acts. There is also a kind of hysteresis. Hysteresis means where is the point where the circuit switches on and where is the point where the circuit switches off. In this case, the relay here is constantly activated, but when we give the negative voltage to the input, and I've done that here, you can see now the positive lead here goes to this point. This is the negative of the other circuit, so this is a 0 now. That's why you see here 0. And also see that in the schematic here 0 is minus, but also 0. So we have different voltages in this circuit, and I mean different in polarity. So this is the circuit. Well, you can, of course, or you must, of course, set at first with this potentiometer this transistor, the second transistor, into conduction. That means that you give it a small positive voltage or positive current, and afterwards this second potentiometer in the circuit pinches that transistor off. And the best way is to do it like I told, with a second transistor. That's used here. This is the second transistor that has a very important function by pinching off. Say, by giving the second transistor a good effect in pinching off and setting the with the help of that transistor, you can set an exact voltage point where the second transistor pinches off. I'm gonna do that now. Here, 2 voltage meters. This is the negative voltage on the input. This is the supply voltage stabilized, so it will not change much anyway. And when you hear a click now, the circuit switches from activated. Now it's activated, you can see it here. So when the relay opens, it's deactivated. So let's listen and see, etc. Lift up the negative voltage here now. Very slowly, that's what I mean. Now you hear the click. Do that again. Now the relay is deactivated. You can see it here. Say by that plate here, it's deactivated. And now it's deactivated on minus 16.4 volts. And now I bring back the negative voltage to a lower value, and let's see when the relay is activated again. I do that I make very tiny differences. Tuning this potentiometer, by the way. Let's see when we hear, well, it clicked. You could hear it, and now it's activated. So on minus 13 it's on minus 13 volt the relay is activated. And now I will turn up the voltage again, the negative voltage again, to see where I can deactivate the... Now it clicks. So, and now we'll do it in a coarse way to show what happens in the circuit. So I'm doing this. You hear the clicks. Activation, deactivation. Let's look here. So this is what happens in the circuit, and because I do now in a very quick way all kinds of changes in the driver voltage, the negative driver voltage, you can see that it works. And that's more or less all that I want to tell. With this potentiometer here, 47K, you can set to an exact voltage, where negative voltage, that's what I mean, where it switches, where the relay switches. And I've made a table and I want to show it finally. So these are experimental results with this circuit. So here you can see, read in a certain way, the hysteresis of the circuit. In this range, 9.2 volt up to 9.3 volts, the hysteresis is very small. Say the difference between where the circuit switches on and off. But when you go to higher voltages, higher negative driver voltages, the hysteresis changes to approximately 2 volts here, 2 volts here, say 1 volt here, and here it is in a lower order. Thanks for watching. This was all. I think it's an interesting circuit, and well, you can get a kind of delay in how the circuit switches by using a 470 microfarad electrolytic capacitor that bridges the relay coil. And that's more, say, a way of using such a capacitor for other relay circuits. You can make the relay act in a certain way sly. And that's why, so that capacitor here gives delay on how the whole circuit works. It has to be a quite high value, 220 microfarad, 470 microfarad. I've used in experiments even 1000 microfarad. It depends, of course, also on the DC ohms resistance of the relay. They form in a certain way a time-dependent circuit. Anyway, could be useful the use of such a delay capacitor. Thanks for watching again.